A lot of questions and comments came out of that Vortex video, and some of that was my fault. I did edit out a lot of the intermediate steps, sort of the setup and adjustment to get the results that you saw in the last video. And before this becomes my boy's next golf club, I thought I could try to answer at least a few of those questions. That, and any excuse to get another thermal thumbnail. So bear with me just a moment while I get all this stuff set back up, and we'll dig right in. To make this a little easier on me, I'm going to add this small inline valve. Saves me from walking across my shop to shut off the air. I expect this to leak a bit, but conserving air isn't really the motto of this device. Hopefully that does it. Sounds nice. I got quite a few comments asking me about the adjustments, the effects of different tube lengths, where the hot spots happened, if I had any control over sort of the temperature difference from one end to the other. And I did all that. I have some answers for you, and I'd like to walk through that now. I cut that out of the last video because I just sort of wanted to get to the point there. But before I get into that, let me show you what's happening sort of right out of the box. I've got 70 psi air in, and I've got the cold side completely open. There's no valve here. It's as if the valve were screwed all the way out. Now, I don't know if all tubes will do this. I suppose it depends on the relationship between the hot side diameter and the cold side diameter. But mine, with the hot side open, creates a vacuum on the cold side. It's sort of a Venturi effect. When the air comes past the small orifice on the left-hand side, it draws in the atmospheric air and sort of pulls it along with it out the hot end, or what might become the hot end. And of course, if I cap the right-hand side, the only place the air has left to go is out the left-hand side, out the cold end. The other thing I'd like to try to show you is that the larger diameter very much has some vortexy stuff going on. Let's talk about the spool problem. I mean, it's not really a problem if you're a normal person. It comes to mind every time I pick up a roll of Teflon tape, or plumber's tape. And seeing as we've slipped into the seedy underworld of science, I thought I'd share. So, like I said, standard issue regulation roll of Teflon tape. I'm going to mark the wrap direction so you can keep an eye on it. I'm also adding a small slug of metal just because this thing is just too darn light and it keeps falling over and going all over the place. I'm going to pull the tape to try to unwrap it, and you watch what the spool does. Let me try to pull it up now. Now the wrap direction, or the unwrap direction, hasn't changed. I'm just going to pull it off to the right-hand side. Pulling it to the right in this case, or still in that unwrap direction, makes it wrap itself back up. And pretty darn fast, too. Maybe you just gotta try it for yourself. Personally, I don't know how plumbers ever get anything done. Maybe that's why they charge so much. Anyway, that concludes our pointless tangent for today. The swirl chamber, and the way the swirl chamber is designed, is actually resulting in a vortexy tube. I hate to beat a dead horse, but that's important. If you don't have a vortex going both directions, it doesn't matter how long the tube is or what kind of adjustments you do, it won't be a vortex tube. You know, on second thought, I think I will beat a dead horse in this case. So I made a little hula skirt. I like to make these for all my tools. Not sure if you can make out the way those things have knotted themselves up. Strands are in the direction that we'd expect coming out of the swirl chamber. That whole thing we saw with the plastic slug that seemed to show that the vortex was spinning in the wrong direction was a little bit misleading. Vortex is going the right way, but this is a cylinder inside of a cylinder, so it was sort of rolling its way around, and that mark made it look like it was spinning the wrong direction. I'll show it to you with one of these little wax pencils. It's just smaller diameter, so you won't see the rolling effect as much. As the vortex forced the slug around, or the pencil in this case, it was causing it to roll against the inside wall, and the little blue mark, goes in the opposite direction. And the same thing happens on the cold side. Okay, so let's start off with a few of the setup and adjustment questions. Starting off with the shortest tube, and just like before, I've got the 2 meters watching 3 points, the hot side, the cold side, and the middle. Everything is starting off at the same temperature, 18 degrees, that the overzealous X-Tech is telling us is 22. So I'm going to turn on the air, and I'll slowly adjust the valve, and we'll watch what happens to the temperatures. The first time around, this really didn't do anything exceptional. I think there's not enough length to diameter ratio here. It's not long enough for enough of the phenomenon inside to develop and produce an appreciable temperature difference. So I don't know if you caught that, but nothing very exciting happened. I had to choke down the valve on the hot end almost all the way to get maybe a 4-degree temperature difference. I Do Pyrotechnics would like to know what program I was using for flow simulation. That was DSS Flow Simulation, basically SolidWorks CFD module. Nikolai writes, alcohol works great when machining aluminum parts. You know what, Nikolai? I couldn't agree with you more. In fact, I always keep a steady supply on hand. Stefan G. writes, I kept trying to call, like 100 times. It just kept going straight to voicemail. Stefan, I want to thank you for writing, and I apologize. Sometimes the call volume can get heavy. I just recommend that you keep trying. I'm going to add another 4 inches of tubing. I'll set this up again, and we'll try it again. With the 4-inch extension, or a total hot side tube of about 12 inches, this thing seems to be stabilizing at about 34 degrees on the hot side, 40 degrees in the middle, and somewhere between 14 and 16 on the cold side. Karelian, sorry, not sure how to say that, asks, what do you use for your thermal imaging? I use a FLIR 1 for Android. I think it might actually be called a FLIR, but I personally don't like that and tend to just call it FLIR. I've got it cobbled together on a tripod on a Galaxy Note. For the price, I think you really can't beat what it does, though I think it's still in the gadget territory, meaning it can't compete with sort of an official $5,000 infrared camera. But I use it a lot and it comes in handy. Danced165 asks why or how at the end of the vid was the cold side not welded to the block. Good catch, Dan. Good eye. It was still welded to the block. At one point, I thought I would machine the welds down to make for a cleaner looking Vortex tube. I machined one side and then decided I didn't really care enough to machine the other side down. Now I'm going to swap the 4-inch tube out for about a 7.5 inch tube. This gets me to about 15 or 16 inch overall length. There's nothing magic about these sizes. It just happens to be the cutoffs that I had in this diameter. In the last 2 setups, I've really just only been seeing results when this valve is almost all the way closed. If I close it all the way, sort of the hot effect pretty much stops. It starts to dissipate as the tube cools down. As the valve starts to close down, I really start to see the hot side come up fast. Cody writes to say that there's no bacon on the McDLT. You know what, Cody? I don't know if I knew that, though now I think I know why it's not around anymore. Mr. Get Off the Lawn Before I Call the Cops 222 writes, Vortex Tubes. I'll tell you a little something about Vortex Tubes. Back in '39, after I got my first truck from Harold out by the big grain silos, you know the ones. So surprisingly, not much difference here. I'm getting about the same results as before. A degree or two hotter on the hot end, but not enough, I think, to be significant. The center stays consistently hotter than the end. In this configuration, I'm at 16:1. That's length to diameter ratio. And it's sort of in keeping with what I saw before and what I've read. I think these things start to work at about 20:1 and up, or start to get an appreciable temperature difference at about 20, 30:1. So I'm not completely sure what... Hello? Listen, Mr. Whatever your name is. I hate to be short, but this gag's been done already. You kidding me, right? Again in the vise? Well, I suppose if nothing else, you're lucky to have your phone so close to your vise. Unless... No. Take a deep breath. Turn the vise handle very slowly. Turn it the other way. So I'm not exactly sure what these two commenters are getting at, but I see no reason why a Vortex tube couldn't be made out of wood. But it looked nice. So the last thing I could try here is putting the long tube on and getting back to what we saw in the first video. I'll zoom in on the meters once this thing is up and running. And here we're at the 32:1 length to diameter ratio from the video. And that number came from the charts you saw in the first part based on the work that Hilsch and I did back in the 30s. So that was interesting. It looks like with the same setup from, well, that's really hot. With the same setup from the first video, I'm now reaching a mid-tube temperature, like 58 degrees. So about 8 degrees hotter. Though maybe I just didn't get the hot spot with the thermocouple in that first part. And it looked like it was trading off cold side temperature for an increased hot side. And finally, I got quite a few comments asking what might happen if I put Vortex tubes in series, sort of one feeding the next. And to be quite frank, I have no idea. So I built 50 more. Let's see what happens.